Welcome back. We're still working on this tricky party hat question. But we're almost done. So let's keep going around the basketball here. TU. So now they said TU is 11. Okay. TU is 11, so this whole thing is 11. So again, using this same idea, I know this length, whatever's left over, is 11 minus whatever that is. So if this was 2 or 1, that'd be 10 left, right? So 11 minus this stuff will tell me that side. So let me write that out. 11 minus this stuff will be this missing side. So once again, I'm going to distribute a negative. 11 minus that stuff. And I can think of this as in a different order. 11 take away x, and then take away another 3 would be the same thing as just taking away 3 and then taking away x. So 11 minus 3 would be 8. So this side is 8 minus x, and so that would mean this side would be 8 minus x, because we know that opposite sides of tangents are congruent. Almost done. UV is 12. Okay. UV is 12. So same thing. I know this missing side is 12 minus this stuff. So 12 minus that stuff would be 4 plus x. Okay. So this side would just be 4 plus x, and that side would be 4 plus x, because that's my last party hat. Okay, so my last party hat is 4 plus x, 4 plus x, and now I've made it all the way around the end. I'm going to use this VR. So what's interesting about VR now is I have an expression for one length of VR and the other length of VR in terms of x, and I know that the length of VR is 12. All right, so one side of VR is 4 plus x, the other side is just plain old x, and I know those have to add up to 12. So I should be able to combine like terms. Subtract 4 on both sides. I get 2x is equal to 8. So x is 4. What? That's it? X is 4? So I encourage you to redraw the shape. This is kind of hard, but put it back, put the circle back inside the pentagon. So it's kind of hard to draw the shape. But and then rethink this. Just double check your answer to see if that makes sense. So if that's 4, we said x is 4. Okay, so if that's 4, that's 4. And again, we said this whole thing was 10. So that would mean that'd have to be 6, right? And that'd have to be 6. Well, we said this whole thing was 13. So this party hat here would have been 7. Drawing got a little weird, sorry about that. And so that'd make this side of the hat 7. Well, the bottom of the pentagon is 11. So that would mean that 11, so that'd make this 4. And that 4. So if this was a bunch of party hats on a basketball, one of the party hats was a size 4, one hat was a size 6, one hat was a size 7, one hat was a size 4. We're almost all the way around. They said this length was 12. So that'd make that 8. If that's 8, that's 8. And to double check our answer, we were told this length was 12. So when it's all said and done, that length VR was supposed to be 12. So that means we did get it right. In order for all of these numbers to make sense, x has to be 4. Now the perimeter of the pentagon is not as hard. We didn't have to do any algebra. We could have in fact answered that first because they gave us every single length, and perimeter just means to walk around the outside. So we got 12 and 12 and 10 and 13 and another 11. We could have found the perimeter to begin with, just adding all these up. So 10. I got 58. Cool. Okay, hopefully this one's a little easier. It says we got all these tangent lines. So that means this side's equal to this side's equal to this side, and this last side has to be equal to that last side. 3 party hats on a basketball. So they tell us JA is 9, so if that's 9, that's 9. That's nice. They actually told us this small part. AL is 10, so if AL is 10, this is 10. And last but not least, they said this length is 14. So that's 14. That's 14. Cool. Now they want my perimeter. Oh my goodness, this one's so much easier. So I've got to walk around the outside. I got to walk 9 and 10, another 10 and another 14, another 14 and another 9. So I got to add up all these numbers. It's a little different than the last question because they didn't tell me the whole thing, but I could figure that out. 10 and 9 would make 19 here. So one side of the triangle is 19. 10 and 14 would make 24. And the last side of the triangle, 9 and 14, would make 23. So the perimeter of a triangle, you add up the 3 sides. It looks like one side's 14, one side's 24, and one side's 23. $61. Cool. Now, ooh, this one's like in our notes, question 1B today. This is pretty much, we see a diagonal, or excuse me, a diameter. And so we think to ourselves, whenever I see a diameter, that's a lot of information they're giving me. They're telling me that's a straight line, that's 180 degrees. So if that's 57, I know that this is a straight line here, so they got to add up to 180. So 180 minus 57 is 123. I know this central angle is 123. Now they want to know, what's the angle BAC? BAC. So they actually didn't even need to know that number. Maybe that was just some extra work, which is fine. If I think about it, if the central angle is 51, let's think of that as a pizza slice, then I know that's 57. Then I know the crust is 57. 57, 57. And I know that that angle A is on the circle, so that's a tip of a cone. So I don't even need this number to go, if the tip of the cone creates if an inscribed angle creates an intercepted arc, it's got to be half. So half of 57 is 28.5. And that's all they wanted, 28.5. Cool. All right, this is one similar to the question 3 we had and a couple we had in our work today. They said arc BC is 98. All right, so that's this arc right here is 98. They want angle BCP. BCP. That's it? So that's an inscribed angle. If the vertex C is on the tip of the cone, then whatever arc it creates has to be, creates a relationship with the tip right there. The angle and the arc have a relationship. That's the snow created by that angle, definitely. So the tip of the cone has to be half the snow. Half of 98 is 49. That's it. That's it. Pretty exciting. Okay, check out the last video, and I'll walk through the system of equation.